So in the last video we had seen the exercise 9.1, or in, I don't know if it's a new book, it's 10.1. So, and we studied about the congruency, and we studied that the congruency will be of 5 kinds. It could be SSS test, SAS test, ASA test, AAS test, and RHS test. So that were the different tests. Now we move on to the exercise 2 of this chapter. Now as such it will be related to these questions, because the first exercise was based on SSS and SAS, and they have given that the next one will be based on this and a mixed one. So we'll have the next exercise, that is exercise 2. First sum: in triangle ABC and PQR, angle A is equals to angle Q, angle B is equals to angle R. So we have got the first thing over here, that if I draw a triangle over here, two triangles, again that ABC and PQR, they are given that angle A is equal to angle Q, angle B is equals to angle R. Okay. Which side of triangle PQR should be equal to side AB of triangle ABC, so that the two triangles are congruent? Give reason for your answer. So they are given you that if you want to find out that out of these, which is the side which will be equal to AB. So we know over here that correspondence is this way, that A is corresponding to Q, B is corresponding to R. Therefore, triangle ABC is congruent to triangle QRP. Okay. A is Q, B is R, so C will be automatically P. And if we see the first two letters here, so automatically the first two letters over here will be there. Therefore, AB will be equal to QR over here. Now another thing is that they ask us why. So why do we see that? We see that it is given that the two triangles are congruent. So the two triangles will be congruent by AAS test. Sorry, it will be ASA test. Triangle ABC will be congruent to triangle QRP by ASA test. So because these two angles are there and this is the included side, so here also the two angles and the included side will be there. So the included side will be QR. So the AB will be equal to QR over here because of the ASA test. So this question was just to identify or understand the importance of correspondence between the two vertices. So you need to know that A is corresponding to Q, B is corresponding to R, so automatically AB will be corresponding to QR. Question 3. If two angles and a side of one triangle are equal to two angles and a side of another triangle, then the two triangles must be congruent. Okay, what is given is two angles and one side are equal. Okay, there are two sides and one side of a triangle are equal to another two angles and one side of another triangle. So will it be that it will be given that it will be congruent? No, it cannot be congruent just by this particular data, because if you see this thing, it has to be such that two angles, suppose this are the two angles and this is the side what we are talking about, and here the side is this one. So I have got two angles equal to two angles, but this side is not included, this is included. So can it be congruent? No, it cannot be congruent. So here it is very much important that the correspondence, so you can, the answer over here will be just that it is not true, the statement is not true. Third is no, as the corresponding angles and sides should be congruent. So in this case, it may not be corresponding. In that case, it is not congruent. So that is question number 3. We move on to question number 5. In fact, the exercise starts from 5. Such kind of questions like 1, 2, 3 are never going to be asked. So, not so important at all. Yeah, it just helps you to understand the concept properly, but not exam point of view, see, not important at all. Okay, so question number 5. Let's draw the figure first. Okay. So this is a figure which is given to us. ABCD is a quadrilateral and AC and BD are the diagonals. DN is perpendicular to AC and BN is also perpendicular to AC. So it's given to us that BM and DN are perpendicular to the line segment AC, and if BM is equals to DN, so given first part is BM is perpendicular to AC and DN is perpendicular to AC, BM is equal to DN. So this is equals to this. This is the data given to you. Prove that AC bisects BD. You need to prove that AC bisects BD. That means AC is bisecting BD means what? BE is equals to DE is what you need to prove. Okay, we need to prove that BE is equals to DE. Let's start with this now. So if I want to prove that BE is equals to DE, which are the triangles I need to take? I can see I can take easily these triangles, these two triangles, 1 and 2 over here. Because if I take these two triangles, I already know that this side is equals to this side. This is 90 and this is 90. And this angle and this angle will be equal because vertically opposite. So by AAS test I can prove them to be congruent. So let's directly write those. So we first write, give it, it's already here. So in triangle BME and triangle DNE, BM is equals to DN given. Angle DBME is equals to angle DNE perpendicular given that is 90 degrees, and angle DEN, sorry, I'll take it as BEM is equals to angle DEN vertically opposite angles. So that gives me triangle BME is congruent to triangle DNE by AAS test. Got it? Now if their triangle are congruent, automatically this side will be equal to this side. So therefore DE is equals to BE, right? So D is equals to B by CPCT. Therefore AC bisects BD. Okay, we need to prove that AC bisects BD. So we need to write this last step as AC bisects BD. That is hence proved. So this was the question number 5. We now move on to question number 7. Question number 7. You got two lines intersecting each other at O. This is A, this is B, AD joint, this is B, this is C, and you are given, so two lines AB and CD intersect each other at O such that BC is equals to DA. So this is parallel to this. So first thing is given, BC is parallel to DA, and also given that BC is equal to DA. So this is also equal, parallel also and equal also. Show that O is the midpoint of both the lines AB and CD. Then we need to prove that. To prove O midpoint of AB and CD. That means I need to prove that OB is equals to OA and OC is equals to OD. This is what I need to prove, right? So of course we need to take these two triangles. So let's see first what are the things we can get. We already know that this side is equals to this side. Side to mil gaya. Here that they are parallel lines. Therefore this angle will be equal to this angle, alternate interior angles. Similarly this Z formation, this angle will be equal to this angle. Ho gaya. ASA test. Let's write it down. In triangle AOD and triangle BOC, we have AD is equals to BC given. Angle OAD is equals to angle OBC, alternate interior angles. Angle ODA is equals to angle OCB, again alternate interior angles. Therefore triangle AOD is congruent to triangle BOC by ASA test. Accordingly, we have over here that therefore OA is equals to OB and OC is equals to OD, both as CP/CT. Therefore, O is midpoint of AB and CD. Is it clear? Have you understood this thing? So this is how we are proving the sum number 7. We now move on to sum number 9. Okay, sum number 9, this way. Let's see the figure first. So we have the figure here. So this one is A over here, and then there is this line and this line like this. So this is O, B, C, E and D. Let's see what is given to us. At angle ABC equal to ACB. That means this angle is equal to this angle. Given angle ABC is equal to angle ACB. The first thing. D and E are the points on AC and ED such that BE is equal to CD. BE is equal to CD. BE is equal to CD. Okay. Good. Next. You have to prove that. To prove, first one, triangle EBC congruent to triangle DCB. Second, triangle OEB congruent to triangle ODC. Third thing, OB is equals to OC. Let's see the figures first and see what are we to prove. EBC, yeah, this triangle, and DCB, this triangle. This is very easy. You can see that BE and DC are given equal. This angle given equal. This equal to this given. This becomes the common side. So by SAS test, the two triangles will be congruent. Let's write it down. In triangle EBC and triangle DCB, BE is equals to DC given. Angle ABC is equals to angle ACB given. BC is equals to BC common. Therefore, triangle EBC congruent to triangle DCB by SAS test. Got it? So that is giving me the first part. So this is done. What's the next thing? OEB, this triangle and this triangle. Now what are we having over here? Let's see whether we already have them, anything which is equal, or we can prove it directly. So we just know that BE and DC are equal. I'll put it with a different pen now. So I know that this side is equal to this side. In this triangle, we are talking about this triangle. We are talking about these two red color triangles. That is OEB and ODC. We know that this side is equal to this side. We know that these are vertically opposite angles, right? Perfect. What else? Do I know that this side is equal to this side? No, I don't know that. Do I know this is equal to this? No, that is also not known. Do I know this angle is equal to this angle? That is also not known. But I can see that when I proved that EBC and DCB, the two triangles to be equal, the green one to be equal, I came to know that this angle will be equal to this angle because they are congruent triangles. So I can use that data here. So hence I will write over here angle OEB is equals to angle ODC as CPCT, so that I can use it in the next part. Clear? So now I have got three things. One is this one and the two angles over here. So let's write it out. In triangle, first one is OEB and triangle ODC, we are firstly given as BE is equals to DC given. Angle EOB is equals to angle DOC, vertically opposite angle. And angle OEB is equals to angle ODC, proved above. We have proved above, right? That's why we are just writing there. Therefore, triangle OEB congruent to triangle ODC by which test? AAS. Will be AAS test. So done with this. Finally, OB is equals to OC पूछा है. OB is equals to OC is the part of the triangle, red colored ones. So this and this will be equal by CPCT. So therefore, OB is equals to OC by CPCT. Hence proved. Did you get this? Okay. It was sum number 9 we now move on to sum number 11. Sum number 11. Let's draw the figure first. So this is a figure. They are given that BA is perpendicular to AC, so that is BA is perpendicular to AC, and FD is perpendicular to DE is perpendicular to DF, such that AB. So given me first is BA is equals to DE. BA is equals to DE, and we got BF, that is this small part, is equals to EC. BF is equals to EC. We also got AB perpendicular to AC and DE perpendicular to DF. This is given. Now to prove is, firstly we have that triangle ABC congruent to triangle DEF. Easy one, because you see already this 90 given to you. This side is equals to this side known. The only thing is now I need the hypotenuse. So for an RHS test, RH hypotenuse, we know that this side is equal to this side. If I add FC to both, I get BC will be equal to FE, and it solves the purpose. So that's what we're writing. So write in triangle ABC and triangle DEF, AB is equals to DE given, angle BAC is equals to angle FDE, again perpendicular given, and finally BF is equals to CE given. So BF plus CF is equals to CE plus CF, adding CF. So we get BC is equals to EF. Therefore triangle ABC congruent to triangle DEF by RHS test. Remember here you cannot say SSA test. SSA करके कोई test नहीं है. ASS or SSS. SSA is not a test. It is a special test which is RHS test. That was sum number 11. We move on to sum number 13. Now sum number 13 has got 3 sums. We'll do the first and the third, and then we'll do the 14th ka last sum. Okay, so 3 sums more. We move on to sum number 13. The first sum of sum number 13. 13th A. The figure. Okay, you got over here that it is triangle PQRS QR, having the midpoint over here as X, and they are ST, and we can have one more number over here, U. Okay. And what are the things given to you is Rx and QX are bisectors of angle PQR and RQ. So these are the bisectors Rx. So these are this angle equal to this angle is equal to this angle. So given is first one is Rx bisects angle PRQ, QX bisects angle PQR. Okay, the next is respectively of here XS is perpendicular to QR and XT is perpendicular to PQ. You have to prove that triangle XTQ congruent to triangle XSQ and PX bisects angle P. Okay, XTQ, this triangle, and XSQ, so this triangle. I need to prove that this triangle and this triangle are congruent. Right, I need to prove this as congruent. And also need to prove that these two triangles, I will just mark it what is to be proved. This triangle and this triangle congruent, and this is equal to this is what I need to prove. I need to prove that these two angles are congruent. So first of all, let's take the easy part, that is these two parts. You know over here, this angle are bisectors given to you. This is 90 degree given to you. And this is the common side. So accordingly, we have that by AAS test, the two triangles will be congruent. So easy part first. But only thing is that we will need one more line over here, that is this XU, which is perpendicular. So we'll say construction XU perpendicular to PR. Okay, XU is perpendicular to PR. This is what we will require for the later part. That's why we need to write a construction. Here, first of all, in triangle XQT and triangle XQS, angle XTQ is equal to angle XSQ perpendicular given. Angle TQX is equal to angle SQX bisector given, angle bisector given, and XQ is equal to XQ, which is common. Therefore, triangle XQT is congruent to triangle XQS by AAS test. That's the first part which is done, XTQ, XQS, right? Now we need to prove that PX. So for this, what I'll need is, I will need to prove this also congruent and then this congruent. So it will be a long way out. So first thing is, by this I will prove that therefore XS is equal to XT or XT is equal to XS CP CT. Now you are going to take these two triangles, okay? So we take in triangle XRS and triangle XRU, angle S, that is angle XSR is equal to angle XUR perpendicular given, angle SRX is equal to angle URX bisector, that is the angle bisector, and XR is equal to XR common. Therefore, triangle XRS is equals to triangle congruent to triangle XRU by AAS test. Therefore, we have XS is equals to XU CPCT. Accordingly, now we have that, see, if this is equal to this and this is equal to this will be equal to this. Therefore, XT is equal to XU. XT was XS and XS is XU. So, XT is equal to XU from above. Or what you can do is that put a 1 over here and 2 over here and say from 1 and 2. So now we are going to take these two triangles. So we have in triangle XPT and triangle XPU. We have XT is equal to XU. Proved. Angle T is equal to angle U. Angle XTP is equal to angle XUP. Perpendicular given. And construction. Because the construction came to over here. So this was here also you write construction and given. So we had this thing, and this will be the common side. This will be the common side over here. So PX is equal to PX common. So triangle XPT is congruent to triangle XPU by which test? This is S, this is angle, and this is another side. We have to prove this, so this is not there. So we have got this one, we have got the angle and this one. So is there possibility of SSA? No, there is no test like SSA, but this is 90 degree. So what will it be? RHS. So it will be RHS test. Hence it will be angle XPU or XPT is equal to angle XPU. Therefore PX, that is CPCT. Therefore PX bisects angle P. Got it? So for this part we had a long thing to be done because we cannot do directly anything over here. Hence we had to first, after this two triangles, we do these two triangles, then we prove this and this equal, and then we do these two triangles, and then we proved it by RHS test. The triangles equal, hence the angles are equal. Okay, this was sum number 13A. We'll continue next in the next video.